Hello everyone, my name is Kuan-Yu Peng. Today I will talk about the effect of adding calcium chloride in electrolyte on the removal efficiency of heavy metal in soil by vertical electromagnetic method. Here is my content. My content has introduction, electrodynamic remediation, method, result, and conclusion. I will introduction soil heavy metal and soil heavy metal remediation. Heavy metal, due to their difficult biodegradability, allow plants to absorb heavy metal from the soil and accumulate between animals and plants for a long time. They can potential hazard to the environment and human health. The existing remediation mainly include like physical remediation, chemical remediation, bioremediation, electrodynamic remediation. Physical and chemical remediation can damage the structure of soil, make soil usable, and the bioremediation requires a long processing time. Compared to the previous, electrodynamic remediation does not damage soil structure and requires less time than bioremediation. And in the electrodynamic remediation, the electrolyte solution is the one of the key that affects the remediation effect. So, in my research, I will add calcium chloride to the electrolyte solution to change the original electrolyte. Our electrolyte solution uses effective microorganism solution, and I will call it EM. And next, let's talk about electrodynamic remediation. And how does electrodynamic remediation working? First, we will have a tank filled with electrode solution and place heavy metal soil in it. Next, the electrode plate will be placed on both sides, and we will power on. Because most heavy metal carry a positive charge, so after a while of time, positively charged heavy metal ion will move toward the cathode and attach to the cathode plate, achieve the effect of remove heavy metal for soil. There are many factors that affect the remediation effect, like soil composition, current, electro material, electrolyte efficiency. Our research mainly focused on electrolyte and efficiency. Next, I will show my research method. For my research, I will take the tank and put the cathode under the tank. Next, put film soil into the tank. The soil depth is 30 cm, and I will distinguish 5 areas. Top to down is S1 to S5, and on top I will put the anode. After that, I will plunge in electrode solution. For my research, I will conduct 3 sets of experiments. The difference between the 3 groups of experiments is that different concentration of calcium chloride were added to the prompt electrolyte solution. The concentration is 0 mole and 0.01 mole and 0.05 mole calcium chloride in EM. After all, I will connect anode and cathode to the power supplies. My experiment will be conducted for 21 days, and every day I will record pH, conductivity, and current. For the sampling frequency is once every 3 days. The soil sample were analyzed for heavy metal concentration. After discussing the research method, let's take a look at results. For first result, let's take a look at initial concentration of heavy metal soil. Table 4.1 shows the concentration of heavy metal in soil and standard value for soil heavy metal control in Taiwan. We can look to copper concentration is 2,300 ppm and zinc is 1,300 ppm. The concentration about heavy metal is much higher than agricultural land control standard. The next result, let's take a look copper removal rate. The figure 4.1 is final removal efficiency of heavy metal copper. For this figure, we can know adding calcium chloride before the 9 days is more effective than EM in remove heavy metal. However, for day 9 to day 12, the removal effect of EM exceeds that of adding 0.05 more calcium chloride. After the 12th day, there was no significant change in the removal effect of each group. And the table 4.2, we can know the final concentration for heavy metal copper. The concentration of heavy metal in the on the top area has decreased significantly. However, there are still high concentration of heavy metal copper result in the low layer. The next result is zinc removal rate. For the figure 4.2, it shows the final removal efficiency of heavy metal zinc. Until day 9, zinc removal is very similar to copper removal. The removal effect of EM is lower than added calcium chloride. However, the different thing is on the 12th day, the removal effect of adding calcium chloride is stopped, but removal effect of EM continue to increase before the last day, and the last day, day 21, EM removal heavy metal zinc is higher than added calcium chloride. And let's look about table 4.3. Table 4.3 is final concentration for heavy metal zinc. the top area concentration its layer reaches 0. And although the concentration of heavy metals in the lower layer has decreased, there are still residual heavy metal. Next, let's summarize. Based on the experimental result, we can draw the following conclusion. Conclusion 1. The final removal efficiency of heavy metal copper is 0.01 more calcium chloride to EM better than 0.05 more calcium chloride to EM. We can infer that conclusion 2. For copper added low concentration of calcium chloride to EM is helpful for the electrodynamic remediation of heavy metal copper from soil, but added excessive calcium chloride to EM will reduce the copper removal effect. For conclusion 3, the final removal efficiency of heavy metal zinc is EM better than 0.01 more calcium chloride to EM better than 0.05 more calcium chloride to EM. And infer that. Conclusion 4. For zinc, add calcium chloride to EM of the electrodynamic remediation will reduce the removal efficiency of soil heavy metal zinc. And that's thank you for everyone listen.